Today's topic is a potentiometer. Let me tell you at the very beginning that it's an important topic. Important in the sense that based on this particular topic, based on a potentiometer, we have to do electricity experiments. All right. If we were having our regular classes, we would have started experiments based on this particular thing, potentiometer, by now. All right. Also, you get theory questions also. Basically, you get numericals. And the numericals are fairly simple. Okay. But you need to understand this thing very clearly. It's going to be a lengthy video today. So try to understand the things that I talk about in this video carefully. Okay. All right. So let us start. Potentiometer, basically remember, it is a device that measures the EMF of a cell exactly or correctly, accurately. Okay. Yesterday we spoke about a voltmeter. We spoke about internal resistances of a conductor. Internal resistance of a battery. Okay. So I mentioned in the video that a voltmeter is a device that measures potential difference of cars, okay, but it cannot measure the EMF of a battery exactly, EMF of a cell exactly. It always measures lesser. It only measures something called terminal voltage. This is something I have already spoken about in yesterday's video, okay, and the terminal voltage is always lesser than the EMF. It can never measure, a voltmeter can never measure the EMF of a cell accurately, okay. So the device that measures the EMF of a cell accurately is a potentiometer. All right. Apart from that, there are two more uses. Okay, I've mentioned three uses over here. First, I've already spoken about it, to measure the EMF of a cell. Okay, the second is to compare EMFs of two cells. Okay, basically, we do experiments based on these two. Also, the third one, so we do experiments based on all these three actually. Okay, so to measure EMF of a cell, to compare EMFs of two cell, also to find the internal resistance of a cell. So these are the three basic uses of a potentiometer. Okay, so now let us talk about how it looks. All right, now if you check a textbook, you will see this kind of a picture of a potentiometer. All right, basically it's a wooden board. All right, a wooden board. On that wooden board we have wires connected like this. We have wires connected like this. Now that board itself is a bit more than a meter long. Okay, so each wire will be, this wire is about 1 meter long. So we have about 1, 2, 3, 4, 5, 6, 7, 8. We can have about 10 meters long wire mounted on the wooden board. And these are steel strip, not steel strips. These are copper strips. Okay, these are copper strips, and the wires are connected to the copper strips, and like this. Every wire, so to say, are connected to each other. Okay, if we have 10 meters long wire over here, we could not have a 10 meter long wooden board. Okay, so to mount a 10 meters long wire, people have made an arrangement like this. Okay, all right. So, and to that thing, to this mounted, these are the external connections that we do in the lab. This part is the external connection. This is a battery, a power source, okay, whose voltage, whose EMF you know. And this is the, say for example, a cell with its internal resistance of course, okay, whose EMF value, say for example, you have to determine. All right, so this is the cell. And this is a galvanometer. Remember, galvanometer is an arrangement, is a device, not an arrangement. It is a device which detects current, okay, which detects the flow of current. Okay, it can detect a very small flow of current also. It's a very sensitive instrument. So you have a galvanometer here, and this galvanometer is connected to something called a jockey, which I have represented by a J over here. Now, what is a jockey? A jockey is a metal strip. Okay, metal strip, which say for example, you have a wire over here, and this is the wire. Say for example, the line that I've drawn is the wire, and my pen is the jockey. Okay, so I can place the jockey somewhere over here, wherever I feel like. okay, whichever point I want to touch. Okay, the jockey itself is connected to a wire. The jockey is this thing. If my pen is the jockey, my pen is connected to a wire. The other end of the wire is connected to a galvanometer. The other end of the galvanometer is connected to the cell. Okay, that's the connection like. So basically a jockey is a metal strip, a metallic strip, okay, which you can place, which you can connect to the wire at different points on the wire. Okay, so whenever I place a jockey, say for example over here, I place the jockey, okay, so I'm connecting the galvanometer and this cell to this particular point, closing the circuit thereby. Okay, so that is what a jockey does. If we were in the school, I could have exactly shown you what a jockey is like, okay, and we would actually be working with a jockey also. You would understand better. But for now, just understand a jockey is a metal strip, okay, which is connected to a wire, and you can place the jockey at whichever desired point on the wire, thereby closing the circuits, forming a closed circuit. Okay. All right. Now for our convenience, we do not go on drawing this picture of a potentiometer. We do not go on drawing this picture of a potentiometer. It's a bulky thing. All right. And we of course do not, like I mentioned, do not go on drawing this picture. So for simplicity, what we do is we take this particular portion, this battery, this power source is over here. So this is the power source, okay, whose EMF is V, which is giving potential difference V. Now that battery is connected to AB over here, AB over here. AB has length L, like I've shown over here. So this AB is representing all this wire over here. Okay, so AB is this wire, this length. And this part, the cell, the internal resistance, the galvanometer, and the jockey is over here. From A, we've connected the cell, okay, whose internal resistance is this? Let me call it R. The cell is then connected to a galvanometer. Galvanometer is connected to a jockey. So the jockey is forming the connection or closing the circuit. Okay, so the moment what happens is, see, even if this jockey, if the jockey is not placed on the line, then this lower circuit is not closed. Remember, there are two circuits. This is the upper one, okay, this is the lower one. Now this lower circuit forms a closed loop or closed circuit only when the jockey makes the connection. If the jockey doesn't make the connection, then of course the lower circuit is not closed. Thereby no current will flow in the lower circuit. But even if the jockey is not connected to the line or to the wire, okay, the upper circuit is always closed, as you can see. The upper circuit is forming a closed circuit, so all the while current will be flowing in the upper circuit. Okay, so do remember that. And the moment you place the jockey on the wire, the lower circuit also forms a closed loop. Thereby current will be flowing in two loops, one here, one here. Okay, all right. So that's the thing like. Now what you need to remember is, see, so since we've applied potential V through this power source across the wire AB, so the potential difference across length L is V. So V is the potential difference acting across this at the ends of the wire AB. Okay, so potential difference across length L, the whole length AB is V. Therefore, unitary method, potential difference across length 1 or unit length of this wire. What is the potential difference across unit length of this wire? Okay, so potential difference across unit length will be V upon L, of course. So therefore, potential difference across length L, say for example, you've placed a jockey at this particular point. The jockey is making connection at this point, which is at a distance X. This is distance X measured from point A. Okay, so of course, you know, in a potentiometer, what you have is you also have a scale mounted. Okay, so that scale will take the readings, of course. Okay, so by looking at the scale, you can tell what is this length. You can measure this length exactly. In any potentiometer, you will also have a scale mounted. Remember that. Okay, so therefore, if this is X, so potential difference across length X will be V upon L into x. Okay, now what is important for you to remember over here is this thing. What is the potential difference across unit length? The potential difference across unit length of this wire AB will be V upon L. And this V upon L is what is called potential gradient. And you will see in your book that this potential gradient is denoted by a capital K. Capital K denotes potential gradient. Okay, so remember this. This is important. What to understand what potential gradient is.